Alright, here we are at 3.3, which is our harder physics problems. Let's get started. Objectives: convert quantities from one unit to another using appropriate conversion vectors, use algebraic models to analyze and solve multiple step problems mathematically, use multiple independent equations to solve for multiple variables. Alright, two cars are initially separated by 1 kilometer and traveling towards each other. One car travels at 20 miles per hour and a second car travels at 20 meters per second. Convert all given quantities to metric units if needed. How long does it take for the two cars to meet? A car travels a total distance of 2 kilometers. Travels the first half of the distance at a constant speed of 15 meters per second. It travels the second half of the distance at a constant speed of 25 meters per second. What is the average speed of the car? Here's our vocabulary. We're going to do variable, conversion factor, position, velocity, and acceleration. Alright, formulas for us. Basically, these are all the same formula. They're just rearranged in different forms because V equals D over T is the same as D equals VT is the same as T equals D over V. Same formula, just rearranged 3 different ways. Alright, solving harder physics problems. Two bicyclists approach each other on the same road. One has a speed of 5 meters per second, the other has a speed of 8 meters per second. They are 500 meters apart. How long before they meet? So this is the problem we're going to work. Alright, assumptions you can make. In most problems you may assume the following. Assume there is no friction unless you are told otherwise. We will not have friction in our problems. Velocities are constant unless you know otherwise. Our velocities are constant. Initial position, initial time, and initial velocity are 0 unless you know otherwise. Alright, how do you start? What are you asked for? What is given? What is the relationship? And what is the solution? So these are the steps we're going to go through when solving this problem. Alright, back to here, apply the 4-step method. This is our problem again. So one's going 5 meters per second to the right, one's going 8 meters per second to the left, and they are 500 meters apart. We want to know how long before they meet. So it starts, our first question is, what are you asked for? Time. Time is what's asked for, so that's what we need to solve for. Next, what is given? Looking at what we were given in the problem, it tells us that we have speed 1, speed 2, and a total distance. These aren't really circling up well. So we have speed 1, which is here. Speed 2 is here. And how the distance is here. So speed 1, speed 2, and total distance. Next, what is the relationship? What is the relationship between these? Well, we talked about this. The relationship is the speed is equal to the distance divided by time. And we were given 2 speeds and 1 distance between them. And then the solution will be required more than one equation. So we're going to have to use the equation more than one time to solve this because just doing V equals D over T will not cut it. Alright, multiple unknowns need multiple equations. In this problem there are 3 unknowns. Although we know the total distance, each bicyclist will travel a different portion of the distance. So the guy going 5 meters per second will go distance 1, and the guy going 8 meters per second is going to go distance 2. And they want to know what the variable is for time when they meet. To solve for 3 unknown quantities, 3 independent equations are needed. So brainstorm on your own what 3 equations could be used to solve this problem. Going back to the beginning, all those equations we had, they were all the same equations, just rearranged differently. Alright, looking at this, it says that D1 plus D2 has to equal 500 because they're heading towards each other and they're covering the 500. So whenever you add the distance that the first guy goes plus the distance the second guy goes, it has to equal 500 meters. And our total time for 1 has to equal the total time for 2. So all the times have to be equal. Total time has to equal time 1 and time 2. So our general relationship is velocity equals distance divided by time. Relationship in the problem, basically breaking into its components. The velocity of the first guy equals the distance the first guy travels divided by t. Velocity of the second guy equals the distance the second guy travels divided by t. And this right here, guys, is the final t. If you look, it's not T1 and T2, it's the final t. So solve for D1 and D2. Solve for D1 and D2. So D1 is going to equal V1 times time, and D2 is going to equal V2 times time. All I did was multiply up. All I did was multiply up to get D2 equals V2 times time. Substitute D1 plus D2 equals 500. So, V1 plus V2, V1t plus V2t has to equal 500. Because if you look at this, because we said D1 plus D2 equals 500, if I add the two velocities and times together, they have to equal 500. So all I did was take and said D1 plus D2 equals V1t plus V2t. This is basically what we have here. So instead of D1 and D2, that's our 500 meters. That's where this came from. Solve for the wanted variable. So if that's the case, if I have this, I can factor those t's out to where I get t is factored out, and then you have V1 plus V2 equals 500. That's where this came from, factoring out the t. So if that's the case, and I'm trying to solve for t, they divided by this to get it underneath the 500. So you have 505 plus 8 equals 38.5. Learning to solve tough problems using multiple equations is a very useful skill. For this particular problem, there's an easier way. Let the red bike be your reference frame. So the red bike. Again, we asked for time. We were given the total distance of 500 meters. Then the speed of the blue bike is what we're looking for. Okay, looking at this, they got 13 meters for the speed of the blue bike. That's this. 8 plus 5 gave you this. They added those two together. 8 plus 5 gave you the speed of 13 meters per second. So that's when they put it down here for the velocity, giving you 38.5 seconds. Alright, the importance of units. In solving problems, if units are not consistent, you must convert. For example, how long does it take a car traveling 30 miles per hour to travel across an intersection that is 18 meters wide? What is asked for? Look at your miles per hour and meters, so this doesn't really work. Again, how long? How long means they're looking for time. Then what is given to us? Distance and velocity is given to us. So we have a distance and a velocity. What is the relationship? We have velocity is distance divided by time, like we had before. Well, the solution, if we rearranged and have distance divided by velocity, I have 18 meters divided by 30 miles per hour equals 0.6 seconds. What's wrong here? Well, look, you have meters and miles per hour. There's no way you can get seconds out of those units. So, how long does it take the car to travel? Well, we've got to take 30 miles per hour. We have 1 mile equals 1,609 meters. This mile crosses out with that mile. And then 1 hour is 3,600 seconds. This hour crosses out here, leaving me in meters per second, which is what I have here. Alright, so now if I plug this in and go 18, which is in meters, divided by 13.4 meters per second, now I get 1.3 seconds, which works because these meters cancel, leaving you in just seconds. So converting all the quantities to metric units, or in miles per hour, so a mile cancels here, hours cancel here, so 20 times 1,609 divided by 3,600 gave me this in meters per second. Okay, how long does it take for the two cars to meet? Well, they went D1 plus D2 like we were working earlier. They have to travel the same 1,000 meters. D1 is V1 times time, D2 is V2 times time. Set them equal to each other. Factor out the time, rearrange. You get 34 seconds. 34 seconds. A car travels a total distance of 2 kilometers. It travels the first half of the distance at a constant speed of 15 meters per second it travels the second half of the distance at a constant speed of 25 meters per second. What is the average speed of the car? We want the average speed for the entire trip, which is 2 kilometers, which is 2,000 meters. V1 is 15 meters per second. V2 is 25 meters per second. So V equals D over T. T equals D over V. Our solution then has 2 parts. I had to find the time it takes for both parts. So for the first part of my journey, it took 67 seconds. For the second part of the journey, it took 40 seconds because each one went 1,000 meters. Because each one went halfway. The first half was at 15 meters per second. The second half was at 25. So what happens to find the average? I went 2,000 meters and I had to add T1 and T2, which gave me 107 seconds. So 19 meters per second is my answer. Notice that the average velocity was not 20 meters per second. The car spent more time going slower, so the average velocity was less than 20 meters per second.